Okay, in general, we can write an exponential model, aka an equation for any growth or decay, for which the percentage of change is the same for each time period. So that's what they're going to state for exponential growth or decay. They're going to say like, oh, it increases 15% every year, or they'll say it decreases 10% every month, or something like that. They both use a very similar formula. The only thing that really changes is that if you are increasing, you'll have an addition in your equation, where if you're decreasing, you will have a subtraction in your equation. So again, both equations look very similar. We'll have y equals, we'll have a, which is the same a that we had when we were graphing. It's still your initial value or your starting amount. But we won't have a b on this one because our b is replaced by the fact that we'll have to do something to adjust for the percentage. So we'll have times 1 plus the percentage rate to the power of t for time. Technically, this whole part right here, the 1 plus r, is technically where your b would be. Again, the only thing that's going to change is that for a decrease, instead of having 1 plus the percentage rate, we'll have 1 minus the percentage rate. So I'll write that one out as well. 1 minus the percentage rate to the power of t. I'm going to label what each of these variables represents. A represents your initial value or your starting amount. Initial value. Right. R on both of them is the percentage rate that it's changing, but the percentage rate needs to be written as a decimal. Percent as a decimal. Do y'all remember how to turn percents into decimals? Like if you have 5%, what would that be as a decimal? 0.05. You take the decimal point, you move it 2 places to the left. Another way you can actually think about it is just take the number and divide it by 100. Take the percent divided by 100. Y'all know that's what percent actually means, right? It means per 100, per cent, per 100. Yeah. Yes, now you know. So that would be 0.07, in case you can't remember. And then what do we think t represents? Time, just time. Sometimes it is years. If the percentage rate is given to you as a yearly change, your time will be years. But if your percentage rate is given to you as like a monthly change, your time will be months. It really just depends on how they label it. All right, let's try one. Again, these are the questions that we'll probably need a calculator for, just so we don't have to do 1,000 hours of multiplication. Looking at our first word problem, the population of a country increases or decreases according to variables like birth rate, quality of health care, peace, war, and so on. In times of peace, the population often increases by about the same percent every year. And then here we get our information. Suppose that a country has a population of 1 million people in the year 2000, and it increases by 1% every year. First thing we're going to do is we're going to write an equation to model its growth. So just the equation. Right? So we're going to start with y equals, what would be our initial value? 1 million. And then we'll have our parenthesis. Are we doing 1 plus or 1 minus? Plus. 1 plus, because that's growth. Very good. 1 plus. That 1% as a decimal, what would it be? 0.0. Okay, and then for now I'm just going to write to the power of t for time. Just to the power of t. If you want to, you're also welcome to simplify this in parentheses. 1 plus 0.01. You could also just write 1.01. What was its population in 2001? Well, that should be pretty easy to do. That's just 1 year later. If you want to write the equation, you're welcome to. 1 million times, I'm going to write my simplified parenthesis, 1.01. to the power of just 1 year later. This one's also almost mental math. You could just find 1% and add it to it, but you're also welcome to grab a calculator if you need to. Everybody got one? What did we end up getting? Do we need to round to the nearest whole person, or is it already a whole person? It's already a whole person. What was the answer? 1 million.
you guys have the confidence.
1,010,000. Very good. Again, slightly mental math because you could just find 1% of a million, which is 10,000. Add it to it. That's 1,010,000 people. Okay. The finding the population this year, this one would probably not be mental math. This year would represent how many years since 2000? 25 years. Oh my God. I remember the year 2000, guys. I was in 10th grade. Yeah. Yeah, I was y'all's age.
So you're like...
Yes, do the math. I'm like, great. Yeah, good job.
You look younger.
Thank you. It's a prescription retinol. All right, so we'll have our 1.01 to the power of 25 years later. Definitely one where we want to use our calculator. You can actually type it exactly as it looks, including parentheses and everything. 1.01. To get an exponent, remember that's right above the division sign. To the power of 25 years. If I rounded this to one whole entire person, obviously we're not going to have 0.9 people, so we'd probably round up to the next whole number. So 1,282,432. Yeah. People. Doing okay so far? Anyone remember doing this in Algebra 1? Ring a bell? You probably, yeah. I even think that this is taught, the beginnings of it is taught even in 8th grade math, like real basic forms of it. All right, suppose we purchase, I'm going to go with me purchase. Y'all probably did not purchase a car in 2012, right? Suppose we purchase a new car for $15,000 in January 2012. The value of the car depreciates by 35% per year. It's obviously more or less, like it can be, like if you, like I feel like BMWs, Mercedes don't depreciate as quickly, but other cars do. Like some cars hold their value a lot longer. Also depends on damage to the car, mileage. There's a lot of information that goes into the depreciation value, but we're just going to stick with 35% for the sake of this question. And that actually starts the second the car's driven off the lot. You've heard people tell you that like you buy a new car, like the second you drive it off the lot, it's worth less, like just because you bought it. First off, we're going to write the equation for the value of the car represented in any year. So again, we'll have our y equals. What is our initial value? 15,000. Good. Okay. Depreciating means it's losing value. So are we going to do minus? Good, because this is technically be a decay function. 1 minus 35% is a decimalist, 0.35. Good. To the power of t, just to represent any year. You can also simplify what's in the parenthesis here. If I took 1 and subtracted 0.35, what would I get? 0.65. You're also welcome to write it that way. How can I tell that I did write a decay function?
It's less than 1.
It's less than 1, right. When the base is greater than 1, that's growth, just like the last one. When the base is between 0 and 1, that's decay. So we know we actually wrote a good equation. What would be the value of the car in January 2021? That would be how many years after?
9.
Dang, 9 years later. I feel like cars hold their value more now than they've ever held them before. So 15,000 times 0.65 to the 9th power. Car ain't worth much at that 9 years later. Again, they usually do tend to hold their value a lot better now, so it probably doesn't depreciate 35% per year. In terms of money, we're probably going to round to 2 decimal places, so we're going to take that 8, bump this 7 up to an 8, 310.68. And we'll just say, let's hope not. They actually, a few years ago, there was like a chip shortage in cars, and like used cars were so valuable at that time. Like it didn't matter if it was old, new, just if it had a chip, we were gonna pay you extra for it. All right, backside. We're gonna interest. All right. Bank or other type of financial institution can pay or charge different types of interest depending on the type of account or loan. One of the most common types is just simple interest. Simple interest is actually not an exponential function. Simple interest, the equation is A equals P times 1 plus RT. And I'll break down what each of these letters represents. A stands for the final amount in your account. Final amount in your account after you do the calculation. P stands for what's something in finance called the principal. Principal is really just your starting amount, your initial value, just like it was in the last question. And then we'll have 1 plus, again, percentage rate as a decimal. T stands for time. But do you notice that the variable's in the exponent on this one? Is it? Is the variable in the exponent? No, there's not even an exponent. If this is not exponential, what type of function is simple interest? It's linear. It's a linear function, yeah. Some of the most important loans, home loans, actually just use simple interest, ironically. Other types of interest are going to be compound interest. Compounded yearly and compounded a certain number of times a year. When I say compounded, what happens with compound interest is basically the bank goes in and depending on the number of compounds per year, they're going to calculate the interest that you're owed or the interest that you have to pay if it's a loan, and then they're going to add that to your account balance. So if you are earning the interest, you want more compounds because you end up earning more money. But if you're paying the interest, you don't want as many compounds because you're going to have to pay more interest. They both follow the same formula, so I'm just going to write them as just a 1 here. For both of them, we'll have A equals, which is our final amount. We'll have P, which is our principal. And then we'll have 1 plus the percentage rate over the number of compounds, R over N. And that's going to be to the power of number of compounds times time. Okay. Again, A just stands for your final amount. P is your principal, which is your initial amount. They just use the word principal for money. Percentage rate as a decimal. N shows up in 2 places. N is right here and in the exponent, and it's the number of compounds per year. Number of times they go in and calculate the interest and put it back in your account per year. And then T again is time. Oh, why did I even write this when it was here? For all of these, P is the principal, which is your initial amount. R is the interest rate. T is the number of years. It's there for us if we need it. Before we get too far, let's talk about some words that they're going to use for compounds. Word and then number. Okay. They're usually not going to say, we compound this 1 time per year. What they're going to say is they're going to say compounded annually. What does annually mean? How many compounds per year? 1 time per year. Very good. So your N would be 1. Okay. Other words that I see show up pretty often, quarterly. Yeah, quarterly is 4 times a year. Good. Monthly. 12 times a year. Daily. 365 days. Or 365 times a year. And then the one that confuses the most people in the whole entire world, but anyone who loves Bath and Body Works might understand this one. semi-annually. Okay, here we go. Bath & Body Works semi-annual sale. How many times a year does that happen? Twice a year. It's in the summer, it's in the winter. Yeah. Semi-annual is 2 times a year. And for some reason, this is the one that confuses the most people. Semi-annually just means twice a year. Most common wrong answers, they think it means a half a year, but it means twice a year. All right, let's try some. Suppose you take out a loan of $2,500 to pay for textbooks and fees for 1 semester of college. This is a true story. Get ready to be depressed. $2,500 for books. Oh, higher than that, Lily says. Okay, the bank's interest rate is 5.5%. That's very nice of them. They could have did more. You pay the amount in 1 lump sum 3 years later. So we're going to calculate it using simple interest if they were to compound it annually, and then if they were to compound it monthly, how much we're going to have to pay back in each situation. Starting with my simple interest, my linear function, we'll have final amount equals. The principal is the initial amount, it's the amount that we borrowed, $2,500. Okay. Then we'll have 1 plus, what would be 5.5% as a decimal? 0.055 times the number of years, 3 years. Let's get that typed in. 1 plus 0.055 times 3. So at the end of those 3 years, we got to pay them back, $2,912.50. What usually happens, though, is usually they'll calculate the interest beforehand. So they'll be like, okay, we know that you're going to, wait, did I type it wrong? Who's just looking at me with the stank face? Oh, okay. Who's just like, what? Usually what happens is they'll calculate the interest beforehand, and then what you do is you make monthly payments on it. So then you'll just like divide this by, I don't know, 5 years to pay it off, and then just pay a little bit each month instead of paying it back all at once. $2,912.50. So about how much interest are we paying on that? Yeah, about $400 in interest. That's okay though, we borrowed their money. I guess that's nice of them. We're going to compound that annually now. Annually means, what's my N number going to be? How many compounds per year? Just 1. Okay. So we'll have A equals, our final amount equals, $2,500 initial amount, and then 1 plus the percentage rate, 0.055, divided by 1 compound per year, to the power of 1 compound times 3 years. When you type this in your calculator, do you have to type divided by 1 here? No, that's not going to change the value. Do I have to type 1 times 3? No, again, that won't change the value. So thinking about typing it, we can probably type it a little bit easier. 2,500, 1 plus, again, 0.055 over 1 would just be 0.055. To the power of 1 times 3, which would be just to the power of 3. So at the end of those 3 years, we're going to have to pay back $2,935.60. Is that more or less than the simple interest? It is more. Again, compound's always going to be more, which is a good thing if you're earning the interest. It's a bad thing if you're paying the interest. So like if you bought stocks and like stuff like that, stocks, bonds, it'll be a good thing in that situation because you're earning the interest. Okay, and then looking at compounded monthly. Monthly means, what's my N value going to be? 12. Yeah, 12 times a year. Getting it set up. 1 plus 0.055 over 12 to the power of, don't forget your N also goes in your exponent. Do y'all know how to get the cute little fraction to show up on your calculator where it like stacks it one on top of each other? Yeah, you can do alpha y equals, I believe you can do alpha and literally the button right next to it also, the xt theta, that also works. That only works if you have an updated calculator. Some of the personal calculators don't do that. Like my calculator here doesn't do that. But that helps to get this little fraction here. All right, 2,500 parentheses 1 plus, I'm going to get my cute little stacked fraction. If you need help getting that cute little stacked fraction, ask your neighbor, hey, how do we do that again? What buttons do we push? I guarantee someone in your group knows how to do it. Teach them how. 0.055 over 12 to the power of, you can just type 36. You can also type 12 times 3 if you want to. So at the end of those 3 years, we're going to owe them more or less than the last one? More than the last one. Again, the more compounds, the more money. Bad if you have to pay. $47. Yeah. Question, hon? You got it? All right. Oh, sweet grandma. Here comes grandma question. A new grandma deposits $2,000 into a savings account when her first grandson is born. Everybody say, oh. Her bank offers her 3.2% interest on the account, which is not a lot, but it's not bad for a savings account. Most savings accounts give you like 0.032%. So that's actually good for a savings account. How much will be in the account on her grandson's 18th birthday if the interest is compounded annually, and then if it's compounded quarterly? All right, let's set it up. What's our initial amount? 2,000. We'll have 1 plus. It's always going to be 1 plus for compound interest because interest is always earning, not losing. And then we'll put our percentage rate as a decimal, which would be, what's 3.2 as a decimal? 0.032. Very good. Over annually. Annually means how many times a year? Just one time a year. One time a year, they're going to calculate how much interest she earned, and they're going to put it back in her account for her. To the power of 1 times 18 years, we are waiting to give this to grandson. What would be quarterly? Quarterly means how many times a year? 4 times a year. Guess what most common wrong answer is for quarterly? People think 25 often because of a quarter is worth 25. But it's not 25, it's 4. Four times a year. Don't forget that in value does go in the exponent as well. 4 times 18. So we have 2 that we want to calculate to see how much grandma's going to be able to give her grandson on his 18th birthday. All right, we've got first one, $3,525.86. Technically, I think banks steal the rounding. They always round down. I'm almost positive I've heard that banks won't give you 86, they'll give you 85. Cheaters. Is that a whole lot? You gonna be rich? Not really. You'll be able to buy books for 2 semesters of college, maybe. But that was still sweet of grandma to do that for us. Okay, and then changing it up, now we're compounding it quarterly. Again, try and do your cute little stacked fraction here on your calculator. Mine, I have to push alpha, y equals, and then select the first one. Quarterly to the power of 4 times 18 years. All right, are we rich when it's compounded quarterly? Still not rich. $0.67. Thanks, Grandma.